For this first example, we're going to label our sides with hypotenuse, opposite, and adjacent with respect to the given angle. So given angle, not the 90-degree angle, but the other given angle. Then use the appropriate trig ratio to determine the length of the unknown side x. So in the first triangle here, we have the 90 degrees given, but we also have this 78 degrees in the corner here. So we need to first identify our sides with hypotenuse. So across from the 90 degrees has to be our hypotenuse. And then across from that given 78 degrees is our opposite. And our third side then is our adjacent. So we have now labeled our sides with opposite, hypotenuse, and adjacent. Now we have to decide what trig ratio we want to use to be able to solve for side x. So let's run through this again. So TOA. So when we look at this, we are trying to find the opposite and we have the hypotenuse. The trig ratio that uses opposite and hypotenuse is sine. So we're going to start with the sine of 78 degrees. So we always follow sine, cosine, tan with their angle, is the opposite, which is x, over the hypotenuse, which is 15.4. From here, we're going to get x by itself. Right now it's being divided by 15.4, so we're going to undo that by multiplying both sides by 15.4. There we go, 15.4 goes here. So it's multiplying both sides. It gets rid of it on the right side, and it leaves us with 15.4 times the sine of 78 degrees, which we're going to throw into our calculator to get what x is equal to. So on my calculator, I can go 15.4 times, and then you either go sine 78 degrees, or for mine, I go 78 and then sine, and have to hit equals. And I get about 15.06, which to one decimal place would be 15.1, and our units is meters for this question. All right, so two things you need to remember. First, figure out which side's the hypotenuse, then the opposite, then the adjacent. Figure out which side you are given and which one you're trying to find, and from there you look at your SOHCAHTOA to decide which one of the trig ratios we want to use to help us solve. All right, looking at the next one, we are given the hypotenuse, and across from the given angle would be our opposite side, which we don't know, nor do we really care about. The x is the adjacent. So adjacent and hypotenuse, I think we're going to use cosine. Cosine of 62 degrees has to equal x over 13.8. So the adjacent over the hypotenuse. Again, multiply both sides by the denominator to eliminate the fraction. And then put that in your calculator, and you'll figure out what x is approximately equal to. And again, side lengths, let's go to one decimal place here. So 13.8 times 62 cos equals, that gives me 6.5 if we go to one decimal place there. Now, if you're not getting these answers, let's just check something for a moment. Let's just check the cos of 62 degrees. Remember, you want your display screen to have a DEG or a D in the display to know you're in degree mode. If not, you need to figure out how to change that. For me, if I push the cosine of 62 degrees, you should be getting, as a way to check, your cosine of 62 degrees is approximately 0.4695. If I could just go to four decimal places with that. Of course, it keeps going, but approximately that's what it's equal to. So if you're not getting that and you're really frustrated, try Googling it or send me an email and I'll see what I can do to help you with it. All right, next example, you try. Label your sides with hypotenuse, opposite, and adjacent, and then see if you can figure out which trig ratio you want to use. All right, so it looks like the x is the hypotenuse. The opposite we don't know, nor do we really care about, and we're trying to, or we're given the adjacent. So we're trying to solve for hypotenuse this time. So adjacent and hypotenuse, again, deals with cosine. So the cosine of our given angle, which is 20 degrees, is adjacent, 23.7, over hypotenuse, which is x. Now, again, we got to multiply to undo the denominator to get rid of our fractions. So we're actually timesing by x on both sides. This one gives us a little extra step we have to do. We now have the x times, or multiplying, the cosine of 20 degrees, and that's equal to 23.7. Now to get x by itself, we're going to divide both sides by the cosine of 20 degrees. Divide both sides by the cosine of 20 degrees to eliminate it from the left side, leaving you with x is approximately equal to, and again, I'm going to put that in my calculator, 23.7 divided by the cosine of 20 degrees equals approximately 25.2. 25.2 meters. All right, so hopefully that's working out for you. Next example, determine the value of theta to the nearest degree. So again, theta is our angle of reference. So theta is here. That means this one is our hypotenuse. So first thing I want to do is identify which side's the hypotenuse, which one's opposite, and which one's adjacent. And then that leaves this to be adjacent up here. Now, for this angle, I know my opposite and I know my hypotenuse. So, oh, you've sinned. We are going to do the sine of theta is opposite, 2.7, over the hypotenuse, which is 9.4. And then to get theta by itself, we're going to do the inverse function of sine on that ratio of 2.7 over 9.4. So put that into your calculator. So again, 2.7 divided by 9.4. I want to get that answer. And then I'm going to shift sine. Some of you will just do shift sine and then put the 2.7 divided by 9.4 in brackets. That gives me approximately, to the nearest degree, approximately 17 degrees there. I got 16.7, which rounds to 17. All right, you try the next one. See if you can figure out which trig ratio to use, and then solve for theta. All right, so we have hypotenuse. We don't know opposite this time, but we do know adjacent. So, I need to use the cosine. So the cosine of theta will equal adjacent over the hypotenuse. And then to get theta by itself, we're going to do the inverse function of cosine on the answer we get when we do 11.1 divided by 18.0, which is really 18. And if we put that into the calculator, I believe theta is approximately equal to 52 degrees here, to the nearest degree. All right, the last thing we're going to talk about here is what it means to solve a triangle. Solving a triangle means you're going to find all missing side lengths and angles. All right, so we have that written here. The other thing I want to note is side lengths are often labeled with the lowercase letter of the angle across from it. So in these triangles below, I don't have any X's for the missing side lengths or any letters. So we're going to actually use the lowercase letter of the angle across from that side length. So if we look at that very first example here, can I move? Oh, darn it. Nope. So I'm having trouble moving my screen up, which is unfortunate here, but we'll work with what we got. Currently, we know two of the angles in the triangle. So the third angle is pretty simple to find. We can use the fact that angles in a triangle have to add to 180 degrees. So we could take 180 and subtract the 90-degree angle and subtract the 35-degree angle, and that will give us what angle P is equal to. Oh, I was able to move it this time. I have no idea why. Anyway, mysteries of technology. At least in my brain, that's a mystery, but I'm sure there's a logical explanation for it. So angle P is 55 degrees. So that angle up here is 55 degrees here. All right, what we don't have is what side the hypotenuse length is. So we could either call it hypotenuse, or because it's across from angle Q, we're going to call it lowercase q. And similarly, the other side, the bottom side that's not labeled, that could be lowercase p because it's across from angle P. All right, if I want to solve for either P or Q, let's see what we've got in terms of our angle. And you could either use the 55-degree or the 35-degree angle as your angle of reference. Really does not matter. I'm going to use the 35. This side is opposite, and this is hypotenuse. So I know the opposite. I need to find out the hypotenuse. So, I could use sine. So the sine of 35 degrees is going to equal 8.9 over side Q, or the hypotenuse. And then multiply both sides by Q, divide both sides by the sine of 35, and then that will help us solve for side Q. Sorry, trying to get all my pieces here. So 35 degrees is equal to 8.9, and then divide both sides by the sine of 35 degrees. That will leave us with just what Q is equal to. And you should get that Q is approximately equal to 15.5 meters. Now, you could either use the Pythagorean theorem to solve for side P, or you could just use the P is adjacent. You could use the opposite and the adjacent and solve using tan. So the tan of 35 degrees. And you could even use the 55 degrees to solve for it. In fact, I'm going to do that. I'm just going to switch this. I'm going to use the 55, call this one opposite, and now this is adjacent. And the reason I'm doing that is I find it's actually a little bit easier because I don't have to do the extra step of dividing then by multiplying both sides to get the variable from the bottom and then dividing out. Just what I'm trying to say here. My variable's on the top is what I'm trying to say here. So all I have to do is multiply both sides by the 8.9, and then I can just put that in my calculator and get what P is equal to. So P will be approximately equal to 12.7 meters. All right, try the next one. I'm going to do a solution after the fact, but give yourself a chance to work this out. Okay, I'm going to start with angle T, solving for angle T. You can use the Pythagorean theorem and solve for lowercase letter u, or you could use a trig ratio as well once you get another angle in there. But yes, absolutely, you can use Pythagorean theorem. In fact, maybe that's where I will start. And in using the Pythagorean theorem, I was able to get side u to be 11.7 centimeters. Now to solve for angle T, I'm going to use 14.1. It's the opposite side, and I'm going to use the hypotenuse, which is given as 18.3. So that's the sine ratio. So the sine of angle T would equal 14.1, opposite, over the hypotenuse, which is 18.3. So T will be the inverse function of sine on that answer you get when you divide 14.1 by 18.3. And that, for that angle, I got about 50 degrees to the nearest degree. Then angle U would be 180 degrees. Subtract the 50 degrees, subtract the 90 degrees, which will equal 40 degrees. So we have our three pieces of information we needed to find there. So hopefully that makes sense and you will be okay for your homework.